Hi, in this video, we will be talking about Huffman coding. So Huffman coding is a lossless data compression algorithm. So we can apply this particular algorithm as a source coding before we actually send the data to the receiver. For instance, if we have a sender or a source who wants to send this particular data to a receiver, okay, this source information must be coded. And for coding, we can go for using Huffman coding. The idea of this Huffman coding is to assign a variable length code to input characters. Length of the assigned codes are based on the frequency of corresponding characters or symbols. So input character or input symbol you can interchangeably use. So based on the occurrence of the input symbol, we can assign the code word to them. Okay. And this variable length code assigned to input characters are prefix codes. We have already discussed about this prefix code. Means the codes are assigned in such a way that the code assigned to one character is not the prefix of the code assigned to another character. So that way, if you are assigning, then we call that code as a prefix code. And this Huffman coding will generate prefix codes. And this is how Huffman coding makes sure that there is no ambiguity when decoding. So when a sender sends message, if that message is encoded or source coded using this Huffman coding, then at the receiving side, we can exactly decode it without any ambiguity. Okay. And Huffman code makes sure that every single symbol will have a unique binary code. Okay. And then the compression, what is achieved with this particular Huffman coding is lossless. Also, the Huffman codes are uniquely decipherable code. So in how you are ciphering it, similarly, you can even uniquely decipher it. There won't be any ambiguity at all. So for instance, let's say that I have a sender or a source wants to send some information to a receiver. So this information, we can code it. So there are multiple codings technique we can use. So we can go for fixed length coding. So that's one possibility available. So you already know about this fixed length coding. So it's purely about giving the same length of bit for all the symbols. One easy solution is that you can go for using ASCII code. Okay, so ASCII code is what? 8-bit length, right? So every ASCII code will take 8 bits. Now, if you calculate the number of characters I have here, 20 characters are there, or 20 symbols are there. And for every symbol, if I'm using 8-bit, then 20 into 8 bits, totally 160 bits of transmission will take place. Yeah, it's straightforward, we can go. But here the number of bits, what is getting transmitted is more. So this will eventually increase the time as well as the cost of this particular transmission. Is there any other way we can reduce this particular thing with the same fixed length coding? Yeah, we can. We can just analyze this particular information and come to know what all of the codes are used or symbols are used. So if you see, not all the alphabets are used. I have only used A, B, C, D, E characters. So when I only have 5 different symbols or 5 different characters, I don't need to go for this 8 bits. I can even achieve with the 3 bits unique code, fixed length code itself. So if there was 4 symbols, I would have gone with 2-bit representation, but we have 5, so I have to go for 3-bit. So I can assign, let's say 0000001, 010, 011, and 100. Like that, I can also fix some code word, which is a fixed length code word to these particular symbols. So how many bits we are transmitting now? So there are totally 20 symbols, and every symbol will take three characters or three bits for representation. So 20 into 3. So we need to send almost 60 bits. Okay. Is there any other better way we can perform? And that's where we can think of this particular Huffman coding. And what this Huffman coding will do, it will assign variable length codes for the input symbol or input character. So either character or symbol, you can use these two terms interchangeably. And which character will get the less number of bits? The one which is appearing more number of times. Okay, so that's how this particular Huffman coding algorithm will work. So Huffman coding will analyze the data stream of a file, and then it will assign the shorter code to characters that appear more frequently and longer codes to character that appears very less frequently. And if you just go and analyze this particular input, yeah, we totally have A, B, C, D, E, F. Let me just get rid of these things. Yeah, so we have A, B, C, D, E. And let's also count the number of frequency at which this particular symbols are getting repeated. So for A, it is 3, and for B, it is 9, 2, for C, 2 for D, and 4 for E. So that's what the frequency at which these symbols are repeated. So now based on this particular frequency, we can go and assign codes. And that's what Huffman coding algorithm does. So how exactly we can assign means, so first we need to construct a binary tree. So how the binary tree will be constructed? So binary tree means like a tree which is having a node with two children always. Either no children or one children or two children to the max. So when you construct a tree with that property, then that's the binary tree. Binary means two. So any node can have only two children. Okay, now we have to construct a binary tree with all these symbols alongside with its frequency. So let me first put them in a node. Let's consider these all are the nodes I have constructed from the given input. Let me bring it little up here. Yeah, the same data I have reflected here. So A is repeated thrice, B 9 times, and C2, D2, and E4. So what I have done here is I have arranged the nodes in ascending order according to the frequency at which it is appeared in this particular input. So 2, 2, 3, 4, 9. So now we have to construct a binary tree, and that binary tree should have all these nodes in it. And while constructing binary tree, we have to take two nodes which is having the least frequency of occurrence. So in this, when you put it in ascending order, so we can find the first two is the least to one, right? So let's take these two and start constructing the tree. Let me add this first. And this one. So with these two, I'm just going to start constructing binary tree. Let me bring a root for this tree. And then let me bring this square box to represent the addition of these two frequencies. So when you add these two frequencies, the frequency will come to 4. Now we left with 3 more nodes. And we also constructed one root node here. So now alongside this root node, you have to compare all the other 3 nodes and take the least two frequency nodes. So if we see here, yes, we have totally 2, 4. You can take any 4. Let's go with the same 4 and adding this particular node to the existing tree. So now when I add this, always put the least number towards left and the greater number towards the right side or right side children. Now let me add this as a left children and this is the right children for this particular node. So we started constructing binary tree. Just hold on. Yeah. So now let me put up this particular addition. So 3 plus 4, it comes to 7. Now I have left with 7, 4, and 9. So among these three frequencies, which are the least to 4 and 7? Now let me attach this node 4 to my binary tree. And let me bring in one square box here and then give a left child link as well as a right child link. Now, when you add sum of these two, you will be getting 11. Now, we only left with two nodes, so we can just simply join those two nodes in the tree. Now, I'm bringing 9. I'm putting it towards left because 9 is least when compared to 11 there. And let me construct the tree. We pull this node up. Okay, let me sum these two and give the weight. So it is 20. So almost this 20 is nothing but that 20 different symbols we are sending, 20 symbols we are sending, and that should come to your root node frequency. Fine. So now what we have to do, now we have constructed a binary tree. Next thing, what Huffman coding algorithm tells us, we have to assign binary bits for both the left and right children, left node and right node. So let me just go and randomly assign 0 to the left and 1 to the right. 0, 1, 0, 1, and 0, 1. So now we have assigned the binary bits as well. Now we have to just go and record these bits and we get the variable length coding assigned for these symbols. Now let me write those variable length coding here. And for A, if you go and see, so A can be reached if there is sequence of 1, 1, 0. And that is the code which is generated for A. It is 1, 1, 0. Next, for B, let's calculate it. It's straight only 1, 0. So we are giving the least number of bit code for this particular B because B is appearing more number of time. So if you are giving only one bit, so when we are calculating the overall average bit we assign for this particular information, it comes down. Next for C, same 1, 1, 1, 0. 1, 1, 1, 0. For D, all ones, 4 ones. And for E, so it is 1, 0. If the sequence of bit represents 1 and 0, then that's E. Perfect. So now when we just go and see the number of bit code word we have assigned to the symbol is variable in length. So we are just assigning variable length code to our input symbols. So one symbol will take 1 bit, another symbol might take 2 bit, 3 as well as 4 available here. So now when you just go and calculate the number of bits will be transmitted here. So 3 into 3 because A appears 3 times. So every time you need 3 bits. So 3 into 3 plus 9 into 1. Don't get confused. This is just 0, but it means 1 bit. It is 1 bit representation. So 9 into 1 plus 2 into 4 plus 2 into 4 plus 4 into 2. It is 8, 8, 8, 9, 9. So 18, 26, 34, 42. If my calculation is correct. So you will be transmitting only 42 bits if you're going with this particular Huffman coding. Whereas when you would have gone with the fixed length coding, you would have end up in sending 60 bits, or if you would have gone for ASCII code, then we might have transmitted 160 bits. So that's how this Huffman coding can be used for data compression as well as compressed data can be transmitted. So now we need to notify the decoder also what code we have used for encoding this particular message. So alongside what coding you have, alongside the message, what coding you have used, that information also should be passed. So when you construct a Huffman tree, the result is nothing but a dictionary of code word. So A means this, B means this, like that you will be getting a dictionary of code word. So alongside the information, you will be also passing the dictionary as well. So based on the dictionary or table, based on the table, the decoder will decode the message without any ambiguity. So obviously, this Huffman coding is a uniquely decipherable code, and without any ambiguity, we can decipher the input, which is received here. So that's how this Huffman coding will work.